Hello and welcome back. In this Abaqus thermal tutorial, we aim to perform a welding simulation using a birth and death technique. So without waste of any time, we want to jump on creating the part. Part 1 should be 3D deformable solid extrusion, and this one can be 100. We create a rectangle. This one can be 5 and this one can be 60, and for the width of the model we use the value of 30. And here from partition face sketch we want to create the weld line, so we click on OK on this one, and vertical right would be this one. On the center of this rectangle we create a triangle, which is the weld line, but we want to sweep that along the edge, so we left click on this guy and hold, and we choose this one to sweep and extrude along the edge. We hold shift and we select this rectangle, this triangle, click on done, sweep along edge, and we choose this edge and create the part. So we have this weld line, but we want to select these two parts and make them disappear for now. So by holding shift we select these two, and here we remove selected, so we have only this part. And by left click on this one and choosing define cutting plane, we can use the 3-point and create a couple of more partitions like this. So every time I click everything, I click the scroll button of the mouse so that I can create the parts way easier. So I have 4 equal parts here, and by click on replace all I can replace everything. So this is the part, these are the base metals, and here is the weld line. So the part creation is finished. Now we can go to the property, create a property here, steel, general density. We use temperature dependent data, and from here I can copy and paste the density. Next thing we need is thermal conductivity, temperature dependent, and this is the thermal conductivity. And the last but not least is specific heat. So for specific heat we need temperature dependent as well, so Control C, Control V, we have everything here by far. So we create a section steel and we assign this section to this material, scroll button. Now we have the materials which is assigned. So the property is finished. We can go to the assembly to assemble our model. It can be independent, and the assembly is simply done. Now it's time to go and create the steps. So create step. Step 1 should be heat transfer. Let's create another step, which is step death, and this one should be heat transfer, and the time period should be a short time, 0.1. This one can be 1A minus 2, and everything is okay. We can have 300 for this guy, and we have the step death, and we're going to create other steps. So this step should be 1, 1e minus 2, 1e minus 20, and 0.5, which is the half of this time, and 350, and this one should be 1000. We create step 2, it should be the same. So I pause the video and resume after I finished every step. So steps are created, step death, step 1, 2, 3, 4. Now we need a cooling step, comes after step 4, having a time of 500, let's say 500, yeah, 1000, 1e minus 2, 1e minus 20, and this one should be 250 and 350 for this one. Now the steps are created. Now let's go to the mesh and mesh the part. So from here I select the cells, and by holding shift I select these 4, and I go to the seed edge, and I don't need the bias here, but this one by number should be 4. So if I create the mesh, I see here we have a mesh which is not bad, can be acceptable. So the next thing I need to do is to select this one and select here, replace selected. So we need to create sets and put this, each of the parts in a set in order to activate them, because it's a birth and death. So from set here, manager, I create a set here by element, name it part 1, continue, I select everything and click done. Now I need to replace all, I select this one, I do the same, so create this one, part 2, element, and replace all, third part, replace part 3, element, this is part 3, and the last one we need part 4, element, and this is part 4. We also need to select all of them and put them in a group for the, let's say, weld, for the death. So at first we say all of them are in death position, then we reactive them one by one. I will let you know in the next step. So from assign element type, we select everything, and it should be heat transfer, convection diffusion should be checked, and okay. Now we can go to the interaction. So here, by creating the interaction, I'm going to create interaction in the death step, and it should be model change. So continue, this one should be element, and by here I select the region from the sets, weld, and continue. It should be deactivated in this step, and click OK. Now I want to create another interaction, which is interaction 2 in step 1, model change, it should be reactivated, and element, it should be part 1, should be created in step 1. That's okay. Now we want to do that for other steps as well. So step 2, model change, elements, part 2, continue, reactivated, and okay. We select step 3, interaction 4, model change, elements, part 3, reactivated. This is for step 3. Now we want to do that for the step 4, which is the last one, elements, part 4, reactivated. So we created this one for part 3, this one for part 2, for part 1, and for the weld. Okay, and this should be part 4. That's cool. Now we want to create another interaction, which is the surface film condition. We click on continue. We should select everywhere by holding shift. We select only these surfaces. For rotating, you can either select hold Control Alt and left click, or you can select this one. So as you see, we selected everywhere, and we should select this side as well. So we don't need the bottom part, just the surfaces and the sides. So this one is created. From here it should be property reference, and we need to create the interaction property. It should be film condition, continue, use temperature dependent, and we have these values here. Okay, and the sink temperature can be 30 degrees centigrade, and it is created in all steps. That's cool. Alright, so everything in the interaction is done. Now it's time to go to the load. Create a load here. Step 1 should be thermal body heat flux. I select this one, and let's say 2. The magnitude should be 2. I want to do that for other steps, and this one should be deactivated after step 1. So we need to create body heat flux. I select this one, 2, okay. Oops, it should be in step 2, so I move it to the right and deactivate this one. Maybe we can copy from here, and the step should be step 3. It's way easier because everything else is the same. And copy this one, load 4, step 4, and should be deactivated. Here, yeah, we have the loads, step 1, step 2, step 3, and step 4. We can double check the region, so the region should be changed for this one. We select edit region, and we select this part. That's okay. And for this step, it should be on the 3rd one, so we select this one. And for this guy, it should be step 2, so load 1 step 1, load 2 step 2, step 3, and step 4. Yeah, so everything else is okay. Now the last thing we need to do here is to create the predefined field. It should be in the initial step, and From other, we select temperature, we select all the model, and let's say 30, which is the magnitude. So here everything else is okay, mesh is done. So from the step you can change the field output and only keep the nodal temperature, which is NT, and okay. Now we can go and create the job. So create the job, let's say welding B and D, which is birth and death. So continue, okay, submit. We can click yes on this one. We monitor the job. So I pause the video first and we'll resume after the job is completed. Alright, the job is completed. Now we can go to the results. So this is the last step. I would come back to the first step from here, and we can have plot contour here. Okay, as you see here, everything in the weld zone is in the death condition, and they will be reactivated after we go further and further. As you see here, step 1 is created and the temperature is rising to somewhere above 2000 degrees centigrade, and this is the flux that goes to the next step, and everything is activated here, and this is the final one, and the final temperature in the material is 31.9. so here this is the highest temperature. We might need longer cooling time in order for the material to be cooled down and achieve the temperature of the environment. So as you see here, at first this is the death and everything is reactivated, which is the birth. So this is basically the birth and death model, and here you see this red one is the flux in the welding zone. So we can adjust the things here, that the shape of the molten metal with subroutines, which we are going to discuss in next videos. And also you can have from the option and common, here you can have feature edges to see this one from the top. And let's see whether the root of the weld was melted or not. So as you see here, this is the last step. From here, query information and the node. Here we want to see whether this node is reached the temperature, the highest temperature or not. As you see, this is the node, and we go from the probe value. So here this is set on elements, you can set it on node, and you can choose this one and see the nodal temperature is 2000, which means that this one is melted. But if you select different node values, it reveals different values in different steps. So this is the cooling part, and by this way you can ensure that the root of the weld is also melted. So that's it. I hope you enjoyed the video, and if you did, please like the video and subscribe to the channel to see more videos like this. See you in next video.